Topic 2. Kinematics of linear motion.
Hi everyone, today we are going to discuss the definition of instantaneous acceleration, average acceleration and uniform acceleration. Acceleration. What is acceleration? This video will remind you about the acceleration.
Stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity.
Acceleration can be defined as the rate of change of velocity. Acceleration is the process where the velocity changes. Since velocity is speed and direction, there are only two ways for you to accelerate: either change in speed or a change in direction, or change both.
The mathematical expression for acceleration is change in velocity over time taken. Its SI unit is ms-2. Acceleration is a vector quantity.
The instantaneous acceleration. The instantaneous acceleration can be defined as the acceleration at a specific instant in time. That is, we calculate the average velocity between 2 points in time separated by delta t and let delta t approach 0. In mathematics, the expression shows that instantaneous acceleration is dv over dt. Furthermore, since velocity is the derivative of position with respect to time, which is v is equal to ds over dt, we can write the instantaneous acceleration as d2s over dt2. Therefore, we say that the instantaneous acceleration is the derivative of velocity with respect to time.
We also can determine the instantaneous acceleration through velocity-time graph. In the following figure, instantaneous acceleration at time t is the gradient of the tangent line to the velocity versus time graph at time t. Therefore, in a graph of velocity versus time, instantaneous acceleration is the gradient of the tangent line.
Average acceleration. For a particular interval, the average acceleration is defined as the change in velocity for that particular interval. Unlike acceleration, the average acceleration is calculated for a given interval. Average acceleration is calculated by the following formula: delta v over delta t. Delta v is the change in velocity and delta t is the total time over which the velocity is changing. Its direction is in the same direction of change in velocity. Uniform acceleration. The rate of change of the velocity of a particle with respect to time is called its acceleration. If the velocity of the particle changes at a constant rate, then this rate is called the uniform acceleration. An object moves in a uniform acceleration when dv over dt is constant. On velocity-time graph, the slope implies motion with constant acceleration.